Hey guys, this looks like a fun one. When I place 2, 3, 4, 5 triangles like this, what's the overlapping area? If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, let's focus on this blue triangle. This looks like the smallest side, so it would be the 3. This would be the 4, and the hypotenuse would be the 5. Let's label the angle opposite the smallest side as theta, and that'll be the smallest angle. And then let's focus on the green triangle. This looks like the smallest side, so it would be 3. This one would be 4, and this side would be 5. And then once again, let's label the smallest angle as theta. And let's bring back our other triangle. And then let's focus on this triangle. Since these base angles are equal, the two sides would be equal. This will be an isosceles triangle. And let's bring back our other triangles. I thought about it a little bit, and I'm not sure what to do with this isosceles triangle. So I ended up constructing a semicircle here, getting rid of our triangles and bringing this shading down. What do you think of my little friend? Hello, how are you? I'm doing okay. How are you? Good. This is kind of fun. Yeah, it is kind of fun. What are you doing right now? I'm just trying to stay hydrated. Well, I really appreciate the effort. Please keep it up. Well, thank you. That's very nice of you. So let's bring back our triangles. Let's move the shading up here and let's get rid of the semicircle. And we can also get rid of the dash marks. Next, let's erase this part of this triangle, and let's bring back the labels of 3 and 4. Next, I want to construct a rectangle that has these two sides and these two sides. Since this one is a diagonal and this angle equals this angle, we know that if we extend this one, it will also be a diagonal. And that's universally true. If you draw a rectangle with a diagonal, and then you draw another line that has these two angles the same, then they're both diagonals of the rectangle. And diagonals of rectangles have lots of cool properties. One of them is it splits it up into 4 triangles, and all of these triangles have the same area. They're not the exact same triangles, but they are the same area. This shaded region is the same thing as this lower red triangle. It'll be equal to 1/4 of the entire rectangle. And the area of this rectangle would be 4 times 3. So the area is 1/4 of 4 times 3. And the 1/4 and 4 can cancel each other out. So the area of this overlapping region is equal to 3 units squared. Let's put a box around it. How exciting. And here's tomorrow's puzzle. We have 2 regular polygons. What's the perimeter of the shaded region? So we just want the perimeter. So we're trying to figure out what all of this adds up to. How exciting.